Hello everyone, welcome to yet another video of measurement and instrumentation. So in the couple of videos we are being discussing about the topics in unit 2 which deals with the measurement of power, energy and magnetic measurements, and we are now concentrating on power measurements. So last class we have seen about EDM type wattmeters which are capable of measuring high powers. So it is meant to measure high power factor loads, powers and high power factors. So but if a circuit is operating at low power factor, then the power in that circuit is difficult to measure with ordinary EDM type wattmeters. So the reading of the wattmeter is inaccurate on account of the following reasons: because the deflecting torque on the moving system is small as the power factor is low, even though the current and pressure coils are fully excited. The inductance and pressure coil introduces considerable error at low power factors. So in order to get accurate readings from these wattmeters, it is mandatory to measure low power with some extra adjustments in the same EDM wattmeters, and that is why we are going for LPF wattmeters. So LPF wattmeters are a modification of EDM wattmeters wherein which the power measured to be is low than the current in the circuit is high. So in this case, the pressure coil cannot be connected to the supply side, as otherwise large error will be produced. So because of large current flowing, the current coil and corresponding power loss in the current coil is measured by the wattmeter. So what we are doing is that we are using another compensative winding with the main current coil winding. So hence, if the pressure coil is connected to load side, power consumed by the pressure coil is measured by wattmeter, which is appreciable in comparison with the power to be measured, which is small. Hence, it is the same EDM wattmeter, but with slight adjustment in the connection and modifications in the coils. The same EDM is being used for low power factors also. So in general, we use the pressure coil alongside the supply side, but if you use the pressure coil in the load side, then you can easily use for measuring the low power factor loads. So as shown in the figure we have seen here, we have used a compensative winding. So this compensative winding is connected in series with the potential coil, and which is very similar to the current coil. So this current coil carries both the currents of the potential coil and the total current, and it produces its own field proportional to the current. So the compensating coil carries the current IP, and it also produces its corresponding field. So these fields acts in opposite directions to the field produced by the current coil. Hence the resultant field is only due to the current through the entire circuit. So the error due to the pressure coil will be neutralized. So at no load condition, the wattmeter will not show any deflection, as the resultant current coil field is 0. In case of low power factor, the pressure coil current circuit is designed for low resistance to increase the current flowing through it, so as to have increased torque. In low power factor wattmeter, the value of pressure coil current is 10 times the current in case of higher power factor wattmeters. So thus the error introduced in the measurement is appreciable, which must be compensated. So it is compensated by connecting a capacitor across a part of the series resistance. Since the pressure coil has more inductance, it is compensated by connecting a capacitor in series with it. Series with the pressure coil. So usually the pressure coil is connected from to the load side, but for low power factor loads, the pressure coil is connected to the supply side so as to measure these low powers also. So this is the construction and working of an LPF wattmeter. Hope you have got a clear understanding about LPF wattmeters, which is very similar, or you can say it as a modification of EDM wattmeters only. So With this, we can conclude this topic, and we'll meet you with yet another topic of this M&I series. Thank you.